Okay, I'm just going to do a quick tutorial video on what distributive property is and how do we apply it in algebra. So sometimes you'll see equations that look something like this, and it says 2 bracket x plus 1 equals 4. And what this means is you have two groups of x plus 1 having the same weight as 4. So two groups of x, because of means multiplication. So really this is 2 times the value of x plus 1. Same thing. All of these things here, 2 times the value of x plus 1, or two groups of x plus 1, means the same thing. So if it means the same thing, what we're going to do here is we're going to draw one group of x plus 1 to model it. And then what I would do is I would infinite clone it, excuse me, to have two groups of x plus 1. And then I would say is equal to 4. Okay? So two groups of x plus 1 is equal to 4. So how can I get that without having to draw the picture? Well, what we've learned is that if you have two groups of x plus 1, that means you have two x's and you have two 1's. So when I ask myself, what does two x's look like? Well, algebraically, two x's is 2 times x, or 2x. That's what a coefficient does. It defines how many of the variable you have. So two x's. And you would have 2 times positive 1, which will be positive 2. So what we have done here is we have taken this equation and we have expanded it so that it's something a little bit easier to see. 2x plus 2 equals 4. All right? And this is called expansion. Right? We're expanding it using distributive property. So when you have a question that uses distributive property, I always recommend you put the arrows in there so that you make sure you multiply everything that's in the brackets by that too. Okay? And once you get it here, then you could solve it using your basic algebra sense of getting rid of the constant and getting rid of the coefficient. Okay? So if we had another equation like this, so let's say we had 3 bracket 2x minus 1 equals 6. Well, when I draw this, if I have 2x and a minus 1, and I triple it, doubling it and tripling it, I could see the tripling 2x minus 1 equaling 6. I'll draw my 6 over here. 2x minus 1 tripled. If I was using my expansion, I would say if I took 2x and I tripled it or multiplied it by 3, I'd see that that's going to be 6x's. So tripling 2x would give you 6x's. And tripling negative 1 would give you negative 3. So here's my 6x's here. That makes sense. Here's my negative 3. That makes sense. So when I use expansion here, I end up with this equation. And then I could solve it using my regular algebra sense. Again, I'd add 3 to both sides and then divide both sides by 6. Okay? So all we have to do is whenever you encounter something that has distributive property, just simply take your number that's outside the brackets and multiply it by whatever's inside the brackets to end up with an equation that you've used since grade 7. Okay? So anytime you have an equation, even if it's something like this, so if you had 3/4 multiplied by 1/2 plus x, this isn't an equation you'd see in grade 8, but it's something you could do because all you have to do is be able to multiply 1/2 by 3/4 and 3/4 by x. So here we would have 3/4 multiplied by 1/2, because we can do that. Multiply your numerators to get 3, multiply your denominators to get 8. That would become a constant of 3/8. Then I'd say, well, what is 3/4 times x? Or 3/4 times x over 1, because that's the same thing. If I multiply my numerators, I get 3x. If I multiply my denominators, I get 4. I'd end up with this one. I know this is complicated, but you can see that using distributive property is not something that's hard. All you have to do is really think about multiplying individual parts. Since this first part is really just multiplying of fractions, it's not hard to see where that comes from. And since 3/4 times x is really this, although we've never done it before, you can kind of see where that would come from because you multiply your numerators and multiply your denominators. So distributive property is not meant to be something complicated. It's just meant to be some way to simplify more than one group of something. So 5 groups of x plus 3 would be 5x plus 15 equals 15. Now, aside from expanding there is another thing we can do to solve it. So if I was to draw this and say this is x plus 1, and if I was to say, well, 5 groups of that, that would infinite clone it. There's 1, 2, 3, 4. I'm going to bring this up here for a second. Hello. There we go. Oh, come on now. Go up. There you go. 5 groups of x plus 1 equals negative 10. So everybody can probably see that that's 5 groups of x plus 1 equals negative 10. But what I'm going to do here is instead of expanding it to say 5x plus 5 equals 10, what I'm going to do is I'm going to divide this side by 5. And algebraically speaking, you've learned by now that whatever you do to one side of an equation, if you do the same thing to the other, you keep it equal. And if I look at the picture, dividing each side by 5 is really saying, I know that 5 groups of x plus 1 equals negative 10, but if I divide the side by 5, I get 1 group of x plus 1, which is right here, is equal to negative 2. So each of these scales that I've created here by dividing everything I had by 5 now becomes 1 group of x plus 1 is equal to negative 2. So again, going back to look at that again, I said if 5 groups of x plus 1 equals negative 10, then each group of x plus 1 must be equal to negative 2. And that's what we do, what we call division first. So just take a look at that, see if it makes sense. So if I look at another question, like 2 groups of x, that's the world's worst x minus 4 equals 6. If I divided both sides by 2, instead of saying 2 groups of x minus 4 equals 6, I could say each group of x minus 4 must be equal to 3. And then I could solve it from there. So it really makes your instead of expanding it to make larger constants or larger coefficients, it really makes your job easier because it keeps things simpler. So it is a good strategy for isolating variables when you do have distributive property, but sometimes kids get a little confused as to what to do. So if you're not real good at it, just use expansion. But the better you get at distributive property, the more you're probably going to lean to this method. Does that help?